Students, today class AC circuit containing few resistor. The three important AC circuits: AC circuit containing few resistor, AC circuit containing few capacitor, and AC circuit containing inductor. Now, the first circuit AC circuit containing resistor. So this is a resistor symbol. The circuit symbol for resistor R. R is a resistor. The few resistor connected in series with an AC source. AC source. So AC source symbol sine wave. Now this is AC source. AC source. Now the alternating voltage applied to a few resistor. Now this is the 3 marks question. Derive an expression for current in AC circuit when alternating voltage applied to a few resistor. So this is a simple circuit for AC circuit containing few resistor. Now the resistor are connected in series with an AC source. AC source symbol sine wave. So this symbol indicates AC source. A few resistor connected in series. So the AC source, the source voltage V equal Vm sin omega t. The AC source voltage, AC source V equal to Vm sin omega t. V is a source voltage. Vm is a peak or amplitude, peak value of alternating voltage. Omega is an angular frequency of AC. So V equal to Vm sin omega t. Now current in the circuit. Current in the circuit according to Ohm's law, V equal to IR. V equal to IR. Now I equal to V by R. I equals V by R. Now here I symbol I equal to V by R. The current in AC circuit containing few resistor I equal to V by R. So I equals, now V equal to what? Vm. Vm by R sin omega t. I equal to Vm by R sin omega t. Now here V by R. V by R equal to what? I. So now Vm by R equal to Im. So now I equal to Im sin omega t. Sin omega t. Now two important equations are there here. V equal to Vm sin omega t and I equal to Im sin omega t. So V equal to Vm sin omega t, I equal to Im sin omega t. This is expression for current in AC circuit when alternating voltage applied to a few resistor. From equations 1 and 2, it shows that voltage and current are same phase in AC circuit containing few resistor. So already you know the definition of alternating current. A current which varies periodically with time. The alternating voltage vary with like sine function with time at the alternating voltage. Now here graph. So now graph voltage and time how related in alternating current circuits as per sine function. The voltage vary like a simple harmonic sine function with time. So voltage vary with the sine wave. So this is the voltage line. So the maximum value of alternating voltage is called peak value, that is V0 or Vm. And current also vary with sine function with time. Sine function with time. Sine function with time. So here x-axis omega t, y-axis voltage or current. So current also vary with like sine function with time. So current line here, dotted line. So vary with sine function. So here solid line is a voltage line, V equal to Vm sin omega t. Dotted line is a current line, current vary with the sign function with time. So I equal to Im sin omega t. The maximum value of current is called peak value or amplitude, Im. So Im. So now here current and voltage in a few resistor, same phase at same time. So your angle how much? Phase how much? Pi. Phase P H A S E. So voltage and current in a few resistor, same phase at same time. So here also 2 pi. Now what is the phase difference between voltage and current in few resistor? So the phase of voltage pi, current also pi. So pi minus pi what? 0. So now the phase difference between voltage and current in few resistor is 0. So now two equations are there. V equal to Vm sin omega t, I equal to Im sin omega t. The two equations shows that current and voltage are same phase. So now show the graph. So this graph shows that same phase current and voltage at same time. So your angular phase means pi. Here 2 pi at same time. Therefore the phase difference between voltage and current in pure resistor is 0. So this is the expression for I equal to Im sin omega t. The current in AC circuit containing pure resistor I equal to Im sin omega t when alternating voltage applied to a pure resistor. Students, the one more important concept here, power in resistive circuit. This is also 3 marks question. Derive an expression for power in resistive circuit. Show that P means power, average power equals I square M. Im means peak or amplitude. R is the resistor by 2. Now P equal to I square M R by 2. So show that or prove that the average power P bar equal to I square M R by 2. This is the 3 marks question. So derive expression for power in resistive circuit. What is a resistive circuit? The AC circuit containing a few resistor is called resistive circuit. Now this is the resistor. This resistor R, the resistor of resistance R is connected in series with an AC source. AC source. The alternating voltage applied to a few resistor. The circuit only which contains few resistor, so the circuit is called resistive circuit. Now the average power for one complete cycle of alternating current in pure resistive circuit. The time taken by the alternating current to complete one cycle is called a period of AC. So what is the average power over one complete cycle of alternating current in a pure resistive circuit? Now formula P equal to I square M by I square M into R by 2. The average power over one complete cycle of alternating current in a pure resistive circuit. Formula what? P equal to I square M R by 2. Now prove this formula P equal to I square R by 2. Now we have a pure resistor R is connected in series with an AC source. So source voltage V equal to Vm sin omega t. Source voltage V is the source voltage, Vm is the peak value of AC, omega is the angular frequency of AC, and current in the pure resistor circuit I equal to Im sin omega t. So V equal to Vm sin omega t and I equal to Im sin omega t. Now power P equals V into I. The power, electric power, P equals formula V into I. V is the voltage and potential difference. I is the current. Now symbol here I is symbol. So now P equals V into I. So what is the V equal to what? Vm sin omega t. And I equal to what? Im sin omega t. Im sin omega t. So V equal to Vm sin omega t. I equal to Im sin omega t. The source voltage V equal to Vm sin omega t. V is the source voltage. Vm is a peak or amplitude, peak value of AC. Alternating voltage, omega is angular frequency. The current in pure resistive circuit, I equal to Im sin omega t. Now power in resistive circuit, P equal to Vi. So P equal to what is the V? V equal to Vm sin omega t. And I equal to Im sin omega t. Now substituting this for here, Vm sin omega t into Im sin omega t. Now P equals, so P equals Vm Im sin square omega t. Sin square omega t. Now to calculate average power over one complete cycle of alternating current is the average power. The average power over one complete cycle of alternating current. The time taken by AC to complete one cycle is called period of AC, capital T. How much average power is there? Now applying integral calculus. Now average power. So average power P bar equals integral and integration. So average power P bar equals, so in numerator take integral. So the average power take where to where? 0 to capital T. Now integral 0 to T. What? Vm Im sin square omega t into dt. So denominator also take integral 0 t into dt. So students, you see that, you observe carefully here, average power over one complete cycle of alternating current. Applying integral calculus, the average power equal to, I will take integral 0 to dt numerator and also denominator 0 to integral 0 to t into dt. So average power P equals, the numerator Vm Im take outside from the integral Vm Im integral 0 to t sin square omega t into dt. So now you take separate this one, integral 0 to t dt. So integral dt equals what? T, small t. Example in mathematics, integral dx x, integral dy y. Now integral dt t. So limits here what? Here 0 t. So t minus 0. So finally get what? T. So in denominator, integral 0 to dt equals how much you getting? Capital T. Integral dt equal to t. So putting limits t minus 0. So now denominator, integral 0 to dt equal to what? T. So this value is there. Now you T. So now average power P equal to Vm Im by T integral 0 to T sin square omega t written as 1 minus cos 2 omega t by 2 into dt. So students, here in trigonometry, sin square omega t, sin square 2 theta, example sin square 2 theta, sin square 2 theta written as 1 minus cos 2 theta by 2, sin square 2 theta. So standard formula 1 minus cos 2 theta by 2. Here also same, sin square omega t, so written as 1 minus cos 2 omega t by 2. In theta place what? Omega t is there. In theta place, which value is there? Omega t. So okay, sin square 2 theta equals this value. So after you separate this part integral. So average power p equals Vm Im by t. Take bracket. Now separate this one integral. First one 1 into dt, integral 0 to t dt minus. So you take this 2, take outside here 2. So once again, friends, this 2 take outside from the integral. So Vm Im 2 into t 2t. So after separating the two parts, integral 0 to dt. So now here integral 0 to t cos 2 omega t into dt. So into dt. So this 2 take here 2t. So 2t. So after separate this separate two parts in bracket, integral 0 to dt, integral 0 to t cos 2 omega t into dt. So now students, here the average power p equals what here? Vm. So Vm Im by what? 2t. So bracket here. Now the first term what? Integral 0 to t dt. Integral 0 to t dt. So already you know that value how much? Capital T. Integral dt equal to t. So substituting limits t minus 0. So now we have capital T. So now integral 0 to t cos 2 omega dt. So this point, I mean mathematics. So this value shows the 0. Cos 2 omega t dt differentiation. So sin 2 omega t by 2. So after substituting limits, finally you get 0. So this value in examination we mention direct value 0. Substitution. Integral 0 to t cos 2 omega t dt. So this value we mention directly 0. So average power p equals Vm Im by 2t into t. Now capital T cancel. The average power p equals Vm. So Im by 2 by 2. Constant V equals I into R. So now a Vm. So Vm equal to Im into R. So average power P bar equals Vm equal to what? Im into R divided by 2 into what? Im into Im. So now students, here average power. So Vm equal to Im into R. So P for average power P equal to what is the Vm value? Im into R divided by 2. So after Im. So average power P equal to Im into Im square. I square M. So So into R by 2. So this is the final expression for the power in resistive circuit. The power in resistive circuit P equal to I square M by R by 2. Im is a maximum peak or amplitude. R is a AC circuit containing few resistor. So this is a average power or power in resistive circuit P equal to I square M R by 2.